So I have opened the page on Virtuale on the practical activity. We closed last class, or basically looking at the same page. I had told you to download all the files. I don't know if you did that already. You did? All of you? Okay. So I did it myself. I changed a bit the PDF, the thing I printed for you on the paper. So if you have a PDF version on your computer you downloaded a few days ago, it's okay. Just minor changes, so it works fine. I organize files in this way. So let me get to my desktop. Before the end of today, maybe. Okay, desktop. This is our folder. Practical activity on GIS is the name of the folder. I store the PDF here, whereas all the data I passed you are under a subfolder. This is not very important. It's just for keeping things organized. Okay? I will be opening the PDF. I just want to illustrate the content to you before we start. Okay. So, practical activity on hydrological GIS tools for the morphological and climatic characterization of catchments. Analysis of a digital elevation model aimed at stream network identification, watershed delineation, and watershed characterization. Okay, so the tools we are going to use implement the algorithm, the main algorithm we discussed during the last class, the D8 method. I have the slides, the theoretical slides open here in case we need to go back to them. And these are the tasks. Considering the 30 meter, this is the resolution, DEM in the zip archive. These are characteristics of the raster file we uploaded in the zip archive. So the format is a GeoTIFF, meaning a TIFF image, but with pixels that are associated with geographical coordinates. And this is the projection and reference system used for the file. Basically, the projection system and coordinate system is embedded in the file, so you don't have to do anything. But just for you to know, each and every GIS layer we use is associated to a specific reference coordinate system, reference system, and projection system. Stream gauge 12, Reno at Casalecchio Chiusa. We can refer to Reno at Casalecchio Chiusa, or it's really up to us, Savio at San Carlo, since we work with Savio at San Carlo in our environment, we could also refer to that catchment. Identify the stream network for a CSA. Do you remember what this is? The critical source area. So the threshold, the minimum contributing area that you need in order to classify a pixel as a pixel belonging to the river system, not the hill slope. Okay? Of 1 square kilometer, compare the automatically extracted stream network with the blue line vector layer. Blue line is a technical jargon. Basically, it's a reference stream network coming from a different source, a topographic map representing torrent and streams. We will compare the reference map with what we extract from the DEM. Okay? C. Delineate the watershed upstream the considered stream gauge. Then point B. I don't know if we will be able to, no, I already know we won't be able to address all these items today, but we will continue on the next occasion. Characterize the study watershed in terms of drainage area, so we want to compute the drainage area, minimum, mean and maximum elevation, average slope if we want, mean annual precipitation instead is a must. For the mean annual precipitation, use another raster layer. It comes from an authority governing regional environmental protection agency in Italy. ISPRA is the name of the authority. Big Bang is the name of the project that provides us with data sets, and in particular, we will be using one of them, an extraction, a tile of a representation of the mean annual precipitation long-term average at national scale. If you are interested, there are links to all the data sources I provided you with. All the raster data sources are actually open access data sources. Anybody can download them and use them, okay? C, select another stream gauge in the study region and repeat the analysis, meaning that, as always, in class, in a supervised way, we will perform all the steps looking at one catchment, Reno et Casalecchio or Savio et San Carlo. I suggest Savio et San Carlo since Savio et San Carlo is our friend now. And then the idea is for you to repeat the same step and check the results you obtained for a different catchment. Okay, one of the catchment upstream, one of those stream gauges we are considering in the study area, which are exactly the same we use in the RStudio application. Okay, so I'm providing you with some GIS layers. GPKG, do you know this? These are basically formats that are becoming more and more common and used. GeoPackage is just a format for vector layers. So inside a GeoPackage, you can find point layers, polyline layers, polygon layers. In particular, basins is a polygon layer in order for you to check the catchment you obtain from the DEM analysis with the reference delineation that comes from a different source. The blue line GeoPackage is a polyline GIS layer with the reference stream network. This is instead a raster layer describing at 1 kilometer resolution, so each pixel is 1 kilometer by 1 kilometer here, the mean annual precipitation in millimeters. This here will be our input data layer. It's the DEM, the digital elevation model we will use as input information to perform all the following activities. And this layer, again, is a tile extracted from an open access data set. SRTM stands for Shuttle Radar Topographic Mission. It puts together data collected during let me give you one that at least is not marked. Okay, this works. It still has the name of the course as it was named last year, yes, but it works fine, okay? Okay. Instead, the one I gave them has the updated name, but they are more or less exactly the same thing. So, Shuttle Radar Topographic Mission, meaning that when the shuttle was up in the higher atmospheres, it did also some laser scanning surveys of the topographic surface of the Earth. and coming, and the DEM we will be using, a 30-meter resolution DEM, comes from data collected from NASA missions. You can find information, and also if you are interested, access the data at the link I provide you here. I did not check all and each and every link, but they should still be working. Please check. Otherwise, just Google SRTM NASA and you'll find DEM, and you'll find the entry source for accessing the data. Then I don't know why this software does this thing, which I don't like. Then you have some notes for the solution, some other references if you are interested to go deeper in terms of understanding relative to the tools we will be using, but the practical activity will be supervised, so I'll be guiding you. The PDF is structured in this way. Basically, there's a table that starts from here and continues. This table lists step by step everything we are going to do. So in case you miss anything today here, okay, there's the recording of the class, but also this PDF tells you step by step anything that needs to be done in order to complete your assignment, okay? So, as an example here, setting the workspace, copy the content of your zip archive to a subfolder in your working directory, okay? We did this already, for example. Then there is a space left blank here for you in order to take notes as we go, if you want to mark down something that you think it's important. So far so good? Everything is clear? You're ready to start?
Yeah. Okay.
You downloaded the data I provided you with somewhere in your system?
This is the new file.
This, well, but the new version is just associated with the PDF I was showing you. In Virtuale, nothing changed other than the PDF. Sorry, I have a bar here now that I'm sharing the screen, and it's difficult for me to see what I'm clicking. I'm sorry, I have to go like this, otherwise. What I was saying is this, Reza, did you download all the files?
From previous activity, yes.
Yes, you did. You exploded the content of the compressed archive zip somewhere?
Yes.
So you're good to go, basically. Okay, let's start. Please, Alan, have a look if the versions of QGIS they're using differ significantly from mine. My version is 340 something, 340. What do you have? Good. One extra point for you at the final exam. And the others?
340.
340?
344.
So 344, you're more advanced. I don't know what you will find in your QGIS. So since you basically are all up to date, no extra point for anybody at the exam, sorry. Okay, let's start. This is, are you already QGIS users? More or less? Did the software open up in the same way? So basically you have three different sections. This with two panels, this one and this one, or not? In particular, do you see this?
Yes.
With the list of all the processing tools, do you have them? You don't. So going up here, processing, click, put a check on toolbox. and that box should appear. That panel should appear. You have processing, maybe it's termed differently, I don't know. Mine it's in English, I don't know about yours. You found it? Okay, now you have the panel. Very good. Now, second check we need to do before we start. Here you have a lookup for the different tools that are already installed in your system. I would like you to digit this, A dot, why, I don't know why I did say A, so I'm getting concerned. R dot W-A-T-E-R, R dot water. Please digit that in the lookup little bar. Is it clear enough or it's too small? Unfortunately, I cannot manage due to the resolution, the size of the font. Can you see more or less?
Sorry, Professor, is this possible if
Not possible.
no, turn off the first row of the lights because...
No, that is certainly possible.
Thank you so much, Professor.
You're very welcome, thanks. No, I thought you were asking, can we increase the size of the font? No. If I do, then I will start losing track. Oh, it's very dark here, but I should manage. Okay, so you did this. Do you see these two guys? R watershed and R water outlet? You don't? We will have big issues then. Unfortunately, you don't have the needed tools installed in your system, so we need to address that problem. When did you install QGIS? You reinstalled it. And is 340? 344. I don't know if there's anything we can manage doing today, because we will start almost immediately using our watershed. Your friend there has it? Your friend doesn't even have a QGIS? No. Okay. Okay. Maybe it's good if you split, the two of you, and you sit side by side with some But the plugin system is an obsolete one. It shouldn't need a plugin to do these things in a newer version. I don't know. My recommendation... Good. This is very good. And my recommendation for you is to remove from your system entirely version 3.44, and since while you are at that, install 340. Why? Because 340 is a long-term release version, whereas 344 is not. It's a developer version, so it might even not be as stable as the 341. Okay? Ready to go? Good. So, I will do exactly what you need to do. I will follow step by step the itemized list you have in the table. So, copy the file we did. Start by saving a new QGIS project. So, I'm doing the second point on the list. With new layer format, this is not really that important, but it's a clean way to work in QGIS, to start by saving the project and setting the general properties of the project. So I'm going here, menu, project. I pull down the drop-down menu, save as. A Windows pops up. Then I point to the folder where I want to work, which is not Dropbox, but desktop, sorry, I got confused. Our folder, practical activity in GIS, and here I will save a project. So QGIS application. Save. This generates a single file, the extension of the file being QGZ. What is a project file? It's simply an accessory, a technical file that tells QGIS what to open, which layers to upload when you start working on your activity, how to represent the layer, the legend you use, the color you use, so that you can start from exactly the point where you left when you close the application, okay? It's just a technical file. I'm clicking on the project. I don't know why it did something like that. Basically, the project was closed. Double clicking it, it's open. And now the central panel, which is the map, should look empty. White in my case. Maybe you don't have a darker version, but so we are all here, right? Okay. Another very good thing when you're working with a specific projection system, another good thing to do is to set that projection system as the projection system of the whole project. Where do you do that? You go project, properties. These are the properties of the project. Okay? QGIS can adapt layers that are, for example, in geographical coordinates to a project that is in UTM reference system by doing an automatic warping of the layer. Okay, so one thing is the properties of a layer, and one thing are the properties of the project. We are setting the project so that we set how we will visualize on the map the layers. Right now, the coordinate system here, you have a little tiny box here. The coordinate system is in degrees, so this is long reference system. We will change it to the reference system used by all layers I have passed you. I save all the layers using the same reference system. It's noted here, point A, UTM 30-second fuse, northern portion, and coordinates in that systems are in meters, not in degrees any longer. Okay? So I'm going here, properties, windows that more or less looks like this should show up. In your case, it will be different because perhaps you never used this reference system, so you won't have it here where recently used coordinate reference systems are listed, but it's not a problem at all because there's a look up box and you can look up exactly that coordinate reference system by name, by ASCII string, or even better, by unified identifier, a code. The code is called EPSG code. It's a number, it's numeric, okay? And it identifies exactly a reference system and an ellipsoid, a reference ellipsoid. So if you look at the PDF, you have noted down the reference system at point 3 in our list, right? The code, which you can already tell from my computer, but you don't have it, the code is 32632. This is a universal code identifying that very reference system. So I just have to type here 32632. And see, the list here of reference system shrinks, and you should just have this one. This is a reference system that is used for part of Italy, basically the northern part of Italy. And the coordinates, I'm telling this for your reference, coordinates are in meters, not anymore degrees. So you can double click on it or select it and then say apply. And you can then close the window. If everything went well, down here, now the coordinates will look like strange numbers. Those strange numbers are in meter, the longitude and latitude. Okay? Okay, let's save now our project since we made this change. And I will forget saying it and I will forget doing it. But it's very good to save every once in a while the project. So you update the file. If your system crashes, and this may happen, keep in mind we are using open source software. So sometimes something can go wrong, but if you remember saving frequently the project, you'll be able to start exactly from where you left. Is this sufficiently clear? Good. This part you can do yourself. As soon as we will be using that tool, you will notice. Okay. Now, add string gauges as vector layer. In order to add a new vector layer, there are several ways. Where is it? Layer. Data source manager, for example, or this button here with a lot of different color sheets and a plus. Do you see this button? They do exactly the same thing. They open up a window which is maximized. I don't know why in my system, so I don't see anything anymore, but it shouldn't be a big problem. So I'll continue with the maximized window. So these are all the different GIS layer format and kinds you can work with. I mentioned only vector and raster, but as you can see, there are many more. Vector and raster are the most common ones. We want to open a vector layer, so make sure this is highlighted. I have to move back to the light version because I don't know if it's very clear what is highlighted here. But what I want to say is that if I click here, then raster is highlighted, and what I am prompted is the location of the location where the raster file is stored. Whereas if I click here, the system expects from me a vector layer. Okay? So there are 3 dots here. Do you see the 3 dots? We open the data folder and we upload stream gauges geo package. Open. There's a button down here, add selected layer to map, and close. And then it stays like that. I don't know why it does this. You should see something like this. Some dots on the map. If you don't, you skip one passage. Are we in sync? Good. This is a point layer, and normally point layer should be on top of everything else in the table of content or layers list. So point layers should be on top of raster layers. Why? Because a raster layer masks anything that is below. But now we have just this layer. Of course, you can customize the way in which you are visualizing these dots. So for example, I can open for Windows user left button or two fingers as you are used to, I don't know, properties, symbology. Here you can customize shape, color. I don't want to lose a lot of time on this, but for sure we could increase a bit the size so that we see better these points. I hope 4 is good. And I'm selecting big black dots because they are more visible. And also it could be useful to identify these dots on the map using labels. Okay, you see there's also a tab labels here. Currently there are no labels associated with the layer, but I can pull down this and select single labels. Okay, if I select single labels, I can use a field in the table of content. I forgot to show you the table of content, but I will. I can pull down this drop-down menu now, and what I see are all the fields in the attribute table of that GIS layer. There is the code, the site, which is a name. I can opt for code. I can use a white mask by click Y. Now everything is white in the background, but very soon we will add layers below, and in order for the text to be more readable, we can add a mask. We can enable a mask, make it a bit larger, for example, and have the mask color white, which should be already like this, and press OK. These numbers are a bit small on my window. In case we want to increase, we can select properties again or double click. Double click on a layer will open up properties. I can increase the text a bit here, so let's say 13. Okay, now I have slightly larger numbers and I'm ready to go. Stream gauge is a vector layer. The features here are points. Points are identified by 2 coordinates, and there's a one-to-one link of each point to a record entry in the attribute table. So
you repeat the last step?
I just increased the font size. Double click here, labels, text, size. I use these arrows up and down to increase the fonts. I set it to 13 now. If you use left click or 2 fingers here, you can see attribute table. If you click on attribute table, again, in my case it's maximized. Let me try to make it a bit smaller if I can. This is the attribute table associated with that layer. Any vector layer has something like this, some data attached to the geometrical feature. If I keep the other window in the background, probably I have to reduce the size. Window, it's difficult. Where is it? It's difficult for me to move between windows, and every time it opens it maximized. I wanted you to understand that these two objects, the data set and the geometrical feature, are linked, meaning that if I select Reno et Braccia, it's side number 2, this one here. If I select the record, I also select, you see now it's yellow, I also select the geometrical feature. If I select another record here, it's highlighted in the map, meaning that I have selected both the record in the attribute table and the geometrical feature in the map, because in reality they are one thing. Okay? Is this sufficiently clear? This is obvious, you knew that already? Okay, good. Let me close this. Very good. So let's remove the selection. Be careful, having features selected in a GIS. Some tools perform the operation you ask only on selected feature. So keep an eye on what is selected. When you want to remove a selection, there's this button here. And the yellow dot becomes black again. Okay? Now, check the system reference properties we did. Add tutorial DEM. This is an old version. You see indicated, or at least in my version, it says another name. The DEM, we will add the new DEM, the SRTM DEM, 30 meters resolution, by performing the same operation. So, open data source, again. This time we want to open a raster. We navigate where we store the information, and the raster is this GeoTIFF, SRTM DEM, 30 meter, Reno, Romagna. Okay? Open, add to the map, close. And then I have to find again QGIS, which is here. Good. So, I don't see my points anymore, and I have a new item in the table of content panel, right? Rasters should always be lower than vector layer, otherwise they will cover them. So I simply click on it and drag it down. I see again my points, and as you can see, for representing the DEM, the system is using a gray band from -15, which is probably the lowest elevation, to almost 2000, which is the highest elevation. We are all set? All here? Okay, I suggest we change the color band. We customize the scale so that points and labels become visible again. This is done by double-clicking on the layer. Symbology. Instead of single band gray, select single band pseudo color so we can customize the colors. If you do this, a window like this pops up. We are not interested in elevation below the sea level, so the minimum value you can set to 0, which is fine. And the maximum value, if you want round numbers, you can set to 2000. Then, in our PDF, I suggest you to use the red, yellow, green scale, not from 1 to 1200, but from 1 to 2000. And you can select the number of classes you want to have in your legend, but it will linearly interpolate the color, so there won't be fixed classes in any case. So, by pulling this down, I can select more color ramps, and in particular the one I am recommending is red, yellow, and green, that more or less have some green in the floodplains. Okay, lower elevation we will set to green. So I'm using this color ramp. Then here, continues, I select equal interval and I increase the number of classes to a higher number. What I'm suggesting in the PDF is 11 so that we have round numbers in our legend. If you notice, The system is now associating red to lower elevation. We want lower elevation to be grass, green. So I can pull down again this window and invert the color ramp. Okay? These are all customizations. It's not very important. You may want to use a different color ramp altogether. Please go for it. Okay? These are just customization. When you work a lot on a legend, this is not the case, but when you work a lot on a legend, you can save it with this little symbol here. It will save a text file detailing the legend. So if I press all good there? If I press this button here, I can save, maybe not in the data, but outside, in the general folder, I can save the legend, DEM_legend, so that I know what it's about. And this will save a text file that then I can open up and upload with this yellow button here for later uses. I press OK, because now I'm satisfied. And this is the situation. We can squeeze a bit the processing toolbox, and we can expand with this zoom full to any layer that I have in the table of content at the moment. This will also center our view. I don't know where the mask has gone. I see no mask in the text. Do you have the mask, the white mask, or not?
I think the mask is around the corners, not the
Mask or buffer? Sorry, maybe I want to use buffer, not mask. Sorry about that. Buffer, draw text buffer, color, size 1. Let's see how it looks. Yes, much better. It's buffer, not mask. Sorry about that. Good. So we didn't even start, but if you were able to follow me, we're almost ready to start. What should I do? Save the project. I can collapse the legend because it's using up a lot of space. I know the legend of the DM. For collapsing it, I can press this little arrow, and we're ready to go. Now, watershed delineation. Here we need R watershed. It's a tools that belongs to the raster tools in GRASS. What is GRASS? Another GIS system, another open, free and open FOSS, free and open source software that can be a standalone GIS, very powerful to work just on raster, less powerful for vector, and in general less user-friendly. But new versions of QGIS come with GRASS already installed. Perhaps you have to enable the GRASS toolkit, perhaps. Maybe you just have, I don't remember the name, Lilu? No. Perhaps you have to click somewhere for enabling the GRASS toolkit. I don't know, I'm not entirely sure.
Yeah, that's what he said to me, but I tried.
But he was recommending installing a plugin, but I don't know if you can do that any longer. It used to be like that. Old-fashioned was installing a plugin. Go here, plugins, manage and install. Just make this check and see what you have. See if you have GRASS 7, and see if you can add this tick mark.
I have grass GIS, but not grass.
Not GRASS 7, but you have GRASS GIS. Can you put a tick? You can?
Already has a tick.
It has already a tick, and you don't have these tools. This is a problem. Okay. Okay. This is a plugin that comes already with the general software. So if you are able just to install this plugin, not this, Grass 7 actually is deprecated plugin. You don't want that, okay? You want Grass GIS Processing Provider. If you can install that and it works, then you're fine. Otherwise, I recommend do a clean install of QGIS 340. Let's go back to our watershed. What does our watershed do? It performs all the steps that we quickly went through on Monday, the D8 method steps. I double click on it. I have now a dialog window opening up. It's a bit long to fill all the input information. We'll do it slowly. Okay, please check that you have exactly my setting, because sometimes by mistake, touching the touchpad, you change some settings. So let's go step by step, one by one. Surprise, surprise, the input information is the elevation. If you recall, our starting point is the DEM raster layer, from which first step we generate a new raster layer with encoded the drainage direction, so the steepest descent direction. So I scroll this down and I already have all the layers that are in the project. It sees, the program sees just one raster, so it guesses that the raster is the correct one. Location of real depression. This is an optional input. We are not using it because our DEM is already clean. It does not have depressions in it, okay? Amount of overland flow per cell. This is another optional input. Percent of distributed land for USLE. This is a parametric model for predicting the soil loss, erosion. It's a model. So this same tool here can provide you with output that then you can use in famous hydrological model. This USLE one, USLE, is a soil erosion model. We're not interested into that. So here too, see, I just click with the touchpad and it selected the layer. No, we want the terrain blocking overland clean, empty, blank. Minimum size, listen to this very carefully. Minimum size of exterior watershed basin. Minimum size of exterior watershed basin. Does it remind you with anything? No, maybe your answer was correct, but I didn't hear it.
The CSA.
The CSA, exactly. This is what it wants to know. The minimum size of the contributing area for the area itself to be classified as a watershed. And therefore, that pixel becomes an elementary watershed, and that pixel becomes the headwater first pixel of the stream network. Now, the problem here is that it wants the number of cells. It's an optional input attribute. The system uses one that thinks is appropriate with that resolution, but we want to set it. And we want to set it using what is commonly accepted as the order of magnitude of minimum contributing area values. Okay, so 1 square kilometer. We have a 30 meter by 30 meter cell, and that value has to be input in number of cells. What am I going to do? How do we know how many cells?
Feature count of the forms.
That's overcomplicated, feature count. 1 square kilometer. We have a cell that is 30 by 30 meter. What would you do? Divide what by what? First of all, you will think in meters, right? So 1 square kilometer, why you will think in meters? Because our dam resolution is in meter and the projection system is in meter. So 1 square kilometer, how many square meters are 1 square kilometers? 1,000, I don't think so. 1 million, more like it. 1, 2, 3, 1, 2, 3. Whoops. 1 million. 1, 2, 3. 1, 2, 3, 4. No, 10 million. Okay. How many square meters in each cell? And so? 900. Divided by 900. And the result is 1,111, more or less. Okay? This is why in the PDF, minimum size of exterior watershed, bottom of the page, this is the CSA in number of DM cell. That number is around 1 square kilometer. Okay? You have it written down in the PDF file. I'm referring to this. Minimum size of exterior watershed, 1,111. So what I do is to write here 1111. Maximum length, again, the Useley model, we don't like it, we don't use it. Convergence factor for multiple flow direction, we won't be using the multiple flow direction, which is an update of the 8 flow direction. It splits the flow in 2 cells. We are not going into that. We will be using the single flow direction. Single flow direction is the 8 method. Synonyms, okay? So we're not interested into this. We are not interested into this 300, which is associated with computing, I would say, efficiency in computation. Leave 300. Enable single flow direction, D8. Yes, because we're going to use this method. Enable this swap, we leave it as is. Allow only horizontal and vertical flow of water. What is this? This would be a D4 method. Water can just go in the 4 cardinal direction, a simplification of the D8. Use positive flow accumulation even for likely underestimates. Leave it like this. Keep this in mind. We'll go back to it. Likely underestimates. Beautify flat areas. I think this create, I don't even know what that is, so I'm not going to guess, but we're not interested now. Be careful here. Advanced parameters. Number of cells that drain through each cell. Save to temporary file. What is this? These are, the one that follows, a list of output layers that the procedure will generate, okay? All these will be new raster layers. Does this number of cells that drain through each cell reminds you anything that we saw on Monday? Does it? This is sorry about that, the contributing area grid, the number of cells that drains into each cell. This cell here drains 12 cells. It's not the first output raster. The first one is the drainage direction raster. I don't know why it's listed as first, but it is exactly the contributing area grid, okay? Since we want to have a look at it later on, we will not use the save to temporary file option. Why? When you close the project, temporary file will disappear, okay? They are used to store information on a temporary basis. Instead, we want to save it. And we want to save it somewhere specifically. So, you see the three dots here? I'm going here. I see three options. These are the same three options I have in the drop-down menu. Save to file. Save to file, it's suggesting various things, a name and a position. Let's check if I'm happy. In data, I'd like to create a new subfolder within data, which I call output underscore raster, so that I know that everything I find there, it's a raster file I generated working on the study area, okay? I create this new folder, and then the format. The system is suggesting TIFF file, GeoTIFF. It's good. It's a very compact and efficient way to memorize raster and also the projection system. So format, leave as is, TIFF. Name, we know that that's the contributing area raster, right? So we'll call it like that, contrib area, so that I remember what that is. Were you able to follow me? Save. And the window disappeared. Let's hope I'll find it again. I find it again, but it's blank. So this might be a problem. I don't see any other window. Let me just check if I have a window somewhere appended. 0. So I have to start by scratch again. SRTM. Then, please help me remembering if I'm leaving anything behind. Minimum size 1111. Then, maximum length nothing. Enable single flow direction. Save to file. Output raster. Contributing. I don't know what's going on. See? Oh. Maybe we're saved. Save to file. Output raster. Contrib area. Save. Okay. So I don't know why it switches back and forth from this window to the general window, but the important thing, it shouldn't do like this. Perhaps it's the sharing, the screen sharing is the problem. The important thing is that you see your path and the name of the file. Are you in these conditions? Are you in these conditions? Alan, can you have a check? Probably it will speak French. I mean the QGIS version, but maybe you can still manage. Are you in these conditions? Everything is fine? Okay, we can continue. Then you see there's a tick mark here. Open output file after running the algorithm. It's good. Leave the tick mark there so it will run the algorithm and upload in the project the output. I am going down. Drainage direction. Okay, now the meaning now it's clear. This is the drainage direction raster. We want to save this as well. So I'll do like before. save to file, output raster, very good. I write here drain direction, an abbreviation, and I press save. And I go back here. Then, unique label for each watershed basin. This is another output raster we want. We didn't discuss this in class, but it's very interesting to look at it. This is a raster layer with elementary basin, draining into stream segments. We want this as well. So, 3 dots, save to file, sub, it's not correct technically. It's better elementary basins. So, I use as name elementary basins. Format is again TIFF. The location is again output raster. I save it. And I go back to the window. Stream segments is the stream network. I want this file as well. Save to file, stream net. Okay, I'm using short name for simplicity. And I go back here, and the rest, if I recall correctly, should be not interesting to us. So stream segment, the path, and the tick mark on open output file after running. Good. Then half basin. This is used in a hydrological model. We will skip the output, not temporary file. Skip the output altogether. If you don't skip it, the computer computes it, and it will use time. Slope, length, steepness for USLE. Skip. Slope steepness factor again for USLE, skip. Topographic index is an index used in a rainfall runoff, very famous hydrological model called top model, skip. Stream power index again, same thing for top model, skip. This should be it. And we're ready to launch the algorithm, okay? So if we want to have a look at it, it's skip output all the way up to stream segments. Then the other raster output I want, I enable single flow direction, left 305. I set the minimum size of exterior catchment, and the TMDM is the input. So now I do a very important thing, which is with your left hand, cross your finger, because we never know, and press run. You will have if you see red things, it's bad. It can be not that bad, but it's normally bad. Let's see what happens.
We didn't skip the stream segments yet.
Probably it's the same thing I got. No, say it again, sorry.
We didn't skip the stream segments.
Stream segment, no, we want it because it's the stream network. Okay, if I go back to the log of the Python code, as it was going, I saw some errors. You should have the same errors. This is not a fatal error. It's just a warning, basically. Did it finish in any of your? No?
No, I know.
It will take a while.
Yeah.
It's a 30-meter resolution dam, and it's the whole Romagna district. And it's analyzing it all, okay, cell by cell. So these errors are not errors. In running the algorithm, you will see the program is trying to associate a single color to each and every elementary catchment. This is not possible. Catchments are too many. So at some point, it will start repeating the color. It doesn't have enough colors in the palette to identify a single color for each catchment. If you get these errors, but more importantly, this warning, it's not a problem. If you have instead additional errors, might be a problem. How is it going there?
It's
Still working? Let's hope for the best. Did you do this? I told you, I advised
I
you.
have the legs across.
Ah, legs are crossed. Okay, I don't know if it works.
Done.
Okay. While we wait, let's go back to the QGIS. Let's collapse all the legends for the time being, okay? All the legends, let's collapse. We don't want them, so I will collapse this legend, I will collapse this legend. Then, contributing area, drainage direction, elementary basin, stream network, these are all the output raster. These are rasters, so I should drag down below the points, otherwise they will mask everything. So I can select more than one by clicking on the first one, pressing down Shift, and then clicking again on the last one. This selects a stack of layers. Now I can drag them all underneath points. I copied it. Ah, no, okay. It was simply a bit slow. Then we can turn off the layers, one, until we are back to the initial view with just the DEM. And the other thing I do now is to save the project. This is very important, save the project. So that if QGIS crashes now, we're fine. Now, we know that the D8 method produces as the first output the drainage direction. So I will drag down drainage direction and put it here. Then the second output is contributing area. I'll drag down here. Then stream network, and I want elementary basins to be on top. Still working? Everything is fine? Still working? Lilou would be faster, but she doesn't have the tools.
I just reinstalled it and I still don't have it.
Abdi?
Yeah, okay. Mine, when I drag it's not open. I drag
It took a while also in my case.
Yeah, but
Wait a bit.
yeah, it's been like 2 years and
Ah no, do it again. I think you simply did not drag them.
yeah, but it's not responding.
It's not responding. Ah, right. Okay, let's hope for the best.
I did it.
You did it. You can close it and then open up the project file. Perhaps the new output raster won't be there, but it's not a big deal because they are safe. They are in your directory. So. No luck yet? But no, you have an error. It is actually good. I'm concerned because the bar is still to 0%, so it didn't do much. It didn't do much. Okay. So who's with me at the moment? 1, 2, 3, 3. Meanwhile, did you check, Lilu, if you are able to install the plugin?
Yeah, I tried to. I just reinstalled QGIS.
Ah.
And I still don't have it.
You still don't have it. Ask Copilot how to install in your system. So first thing you have to do is ask. If you want, we can discuss this later, but what I would do is asking ChatGPT with the name and number of your operating system, the Mac, how to install a full version of QGIS with GRASS, updated GRASS plugin included.
When I
You killed it.
all the, I try to do it one by one.
But it's not working?
Each time I try to drag the whole mark, it's not.
It's not very important. Just drag up the point layer then, if it's a problem to move around the raster layer. It's not a big deal. The good thing is to have the points on top. Okay. I want to show you a few things that deal mostly, for the time being, with customization. Hopefully, Abdi, you're fine?
Yeah, I'm okay.
Same point? Oh, this is good. Okay. So, let's turn on drainage direction. Turn on, I didn't underline this. There's a little box for tick mark. I think you know this already. If I click, I see a layer. If I click again, I don't see the layer, but the layer is still in the project. So let me also save the layer. This is the hill shaded relief map. Okay? It is simply a grayscale applied to numbering from 1 to 8. Actually, there are also some negative numbers, you will see. But this is basically the layer we're looking at, a layer in which each cell has a number from 1 to 8, and each number is associated with a given gray shade. If I see the legend, I notice that there are also negative values. Negative values are used just on the frontier of the DEM, so the edges of the DEM possibly have some negative values when a cell is surrounded by cells with higher elevation, and therefore the drainage direction would point outside the DEM where we do not have data. So it's nothing to be really concerned about, okay? I want to use a bit the identity tool. We never used it together. So if you look up here, there's an arrow with an eye. This is the identity tool. If I click this and I make sure I have, for example, the DEM highlighted, and I click anywhere in the map, what I see is the value of the given cell. So 574 meters above sea level. Here it's 400. Here on the watershed divide, 771. If I now highlight or select drainage direction and I start clicking around, I see only numbers from 1 to 8. Do you see it? 3, 2, 7, 2, 5. Okay, do you see it? I'm looking at this little panel down here. If I click with the identity feature anywhere, what I see here, it's the value of the cell of drainage direction where I click. 1. It means that the steepest descent is towards east. Okay, so far so good. Did you understand what I'm saying? You're confused by anything I said? I see faces that are not.
Identity tool.
Identity tool is up here. Identify features. Okay, you have to have the layer active, so selected when you use it, so that you are sure that the value it returns, and you can read it in band, the value it returns is the value of that cell. We can change also the scale, because this is not an interesting grayscale to us. Single band is fine in this case. We will be using a grayscale. Instead of -8, which is not interesting to us, I can use 1. Then instead of these double band, I can, sorry, this is not what I wanted to do. Instead of this double gray band, I can select simply grays. I can select equal interval 8 classes, so that each and every drainage direction will have its own gray shade. Okay? Black is associated with 8. In this case, white with 1. If you want, we can save this legend. Where? In practical activity, D8 drainage dir legend. Okay, so that I can use it later on. Yes?
So, because the
What I did,
selections are black on black, so I can't read the name.
Okay.
Like mode,
I left single band pseudo color here.
Okay.
I set the minimum to 1, not to -8.
Okay.
I select grays as color band, so that it starts from white and it ends in black. Then the other thing I did is equal interval, and then number of classes at that point gets unlocked. You put 8. Okay, I saved this legend. And
I don't understand, because I have the gray band, but I'm black too. I mean, the two.
You have white in the middle and the 2 blacks. It's the one it selected because the program noticed that there were numbers from -8 to 8. So it selected that. Okay? But you can change it. You pull down this and you select grays.
So I tried, but
And the minimum value you have to set to 1.
yeah, 1.
Yeah, one, and you set the color palette. Color palette? No, not that. Yeah, grays. Four.
Oh, okay.
Okay. Now, okay, so we recognize the heated shade, hill shaded relief that enhances valleys, divides, and river. For example, this is a divide, and this here is a river. If you want, you can toggle a bit the transparency, setting it, for example, to 30%. So properties, transparency, you press OK, you will see the raster drainage direction on top, and then the DM elevation in the bottom. This gives the map an idea of three-dimensionality. Okay. In fact, if I expand, I will start see the DEM with the relief underneath. This is why it's called hill shaded relief representation. So far so good? You were able to follow me? Good. Now we can collapse. Alan, probably Abdi has some. It's still computing, or it performed the computation? Good. So I'm collapsing now the legend to save space, and next thing I'm going to do is to activate, meaning to make visible contributing area. Contributing area looks something like this. If you use the zoom in, are there issues down there? No? Okay. I have collapsed the legend for drainage direction, and I put a tick in contributing area, so I see the contributing area, right? Now, contributing area has its own legend. Here too, you see, there are negative values and positive values. What is the meaning of a negative contributing area? It has no physical meaning. There's a reason. It's a conventional flag, the minus sign. Okay? But I want Abdi to be with us. Okay? Now I have turned on contributing area. And I have turned on the I have made the legend visible. If you can see, there are large negative numbers and large positive numbers. These are number of cells that drain into one cell. You remember that, right? What is the meaning of a negative contributing area? No physical meaning. It's a conventional flag. We'll see why. Okay? If you zoom in, here, for example, around, or here, let's go to our friend Savio at San Carlos stream gauge. If you zoom around here, we'll see the stream gauge, we see yellows, and we see green, from green to light blue, very dark blue. This is an increasing contributing area, okay? If you activate this layer and you start clicking with the identify feature, in the yellow, you may find values that are rather low. 1, by chance I got 1. 1 means that that cell drains just itself. So if you see 1 intense yellow, it will be a watershed divide cell because it gets no contribution from upstream. It drains only itself. Then if I move towards some more greenish color, I see, for example, 21, I go down, I see 4, no, because I didn't click on the green, I click on the yellow perhaps. Let me increase the zoom a bit more, still around our stream gauge. Identify features, where is it? It's masked, as always. Okay, identify feature. If I click on the green, I get 32, 34, and then very dark blue, a huge number. Those are the cells that are drained by that point in space. Okay? Everything is clear? Okay. I want to go back a bit to the negative values, and in order to explain what they are about, we need to change the contributing area legend. So again, double click, symbology, single band pseudo color is fine. Okay? Help me to remember that the smallest number is 4,600,000. Let's say around minus 5 million. Please help me to remember that minus 5 million is the smallest value ever. Let's set this to 1, which is the minimum meaningful number, meaning that the cell drains just itself. The maximum value, let's leave it like that. It's the largest value the program identified. Then, instead of this color band, let's use one with very vivid colors, like magma, for example. It's good. Are you colorblind?
No.
Good, good for us. So, very vivid color. Then, here, as always, because I want now to touch the number of classes, here, as always, put equal interval. Okay? Equal interval. Now we set the number of classes to 5. And since contributing area increase in an exponential way if you follow the stream, let's customize the legend by order of magnitude. So black to me is 1, good. Purple to me is 10. This other color, lighter purple, 100. This orange color, 1000. 1000 is close to the critical source area. No? Remember that. What we use as critical source area is 1111, right? Last number, leave as is. Okay? Then, do you see here, I scroll up. Do you see here this plus tool button? Press it. Press it once. And right here, minus 5 million. Okay? Set the color to a color that is very different from magma color scale. So for example, green, so that we will identify negative values very well, because green is very different from the other. Do it again. Do it again. Press plus. I changed the label. Sorry, I did a mistake. I didn't want to change the label. I meant to change the value. So minus 5 million. 1, 2, 3, 1, 2, 3. And then here, again, 0 is good, and we select exactly the same color. Meaning that all the negative contributing areas now will show as green. Let me check if before I did a mistake. Yes, I did a mistake. Before too, I just changed the label. This is wrong. What I want to change is the value, not the label, the text associated. Do you understand the difference between these two columns? One is the value, and one is what the legend shows. So the value here has to be in line with the text. If I change this column, it would do automatically an update of the label. 100, 1000, and the last one I leave as is. So we are ready to go. Since it took quite a while to customize this legend, now I really want to save this. Contributing area, legend. Okay? It should be fine. You were able to do exactly what I did. All the negative values are green. Then I have a linear interpolation of the magma color scale. I press OK. And this is just we just changed the legend, okay? But what I want you to see is that there are no negative value, which is good, right? If I zoom out, I have pressed this lens magnifier here with a minus sign, and I can click in the map. If I zoom out, I see no green, no green, 0 green. There's no green whatsoever, no green. I don't see any green cell. If I expand though, and if your seeing is good enough to see these little dots, I can see some green cells here. Let's use the magnifier with the plus now, and let's zoom in near the frontier. You see What are the green cells now? Are cells along the steepest descent direction that drain some cells from the frontier. Okay? If I zoom in again, it becomes even clearer. It becomes clearer that the whole frontier is green. Because the information we have in terms of topographical surface ends there. We do not anything about what's outside. Okay? So it means that this pixel here, that drains pixels here, but also drains pixels here, and also drains pixels from the frontier. This contributing area here might be underestimated. The real contributing area could be larger, but we do not have information here because our tile ends here. So in order to flag possibly underestimated area, the program uses a minus sign. Do you remember when we filled all the optional parameter in the R watershed tool, there was that tick mark, use positive value for possibly under predicted contributing area? We left it blank, so negative values, and these are just conventional contributing area that are flagged because the area could be larger if we had information. Okay? And once a contributing area is possibly underpredicted, it continues. It continues. So if I press the magnifier with a minus, see, we follow that stream, and that stream, then I can use the pan tool. That stream continues to be green, even all the way down until the end of the tile, because it still drains a portion of the topographical surface that we cannot describe because we do not have a large enough DEM. Okay? Whereas if you see orange values, it means that those areas, sorry, if you see orange values like here, for example, this is a contributing area that is not underpredicted because all the pixels that it drains are within the tile. It drains no pixel from the frontier. Okay? Is this sufficiently clear? So negative values are just conventionally flagged. Negative because they're wrong. The contributing area is not complete, most likely. Good. Questions on the things we saw so far? Good. Now, I want you to collapse the legend, turn this off, save the project, turn drainage direction off, and turn on stream network so that we see it. You remember we were in a point where the color of the contributing area was orangish. Orangish, we know that exceeds the critical source area. So as expected, this is a part of a stream belonging to the stream network. Let's zoom out full extent. You don't see anything, right, anymore, because the stream network raster is a very sparse raster. It has values that are different from no data only on the stream network. If, for example, I zoom in here around again our stream gauge number 5, this is the stream gauge, and this is the raster describing the stream network. Okay? Please select this and press the identity feature tool and click on the green. Green means that we are seeing what's below. What's below is the DM. If I turn off the DM, it's white. It is transparent here, right? It is transparent because the stream network raster in all those cells report no data. If you click anywhere outside, it's no data. These are all hill slope cells. They do not drain enough land to be classified as streams. Okay? Very good. Instead, if you click on the stream network, you see a number, 8,960. This, a little bit upstream, still same number. Further upstream, still same number. I click on a different segment, a different number. Another point on the same segment, same number. Another segment below, another number. So the program associated each elementary stream segment with a unique code. Elementary stream segments are zillions, there are many of them. This is why we got that error message. That warning was because it didn't have enough colors in the color palette to assign a different color for each and every elementary segment. Elementary segments are segment between two junctions. There's a junction here and a junction here, and this is one elementary segment, or are headwater segments. So the stream network starts here, and this is a single elementary segment all the way downstream to the first junction. Okay, do you understand what elementary segments are? Now, let's zoom in a bit around this elementary segment. Magnifier. I have selected this because it's short. Let's activate the contributing area layer. Even though I don't see it, now I see it, but it looks like a Matisse painting. Now I don't. Even if I don't see it, it's selected. So if I use the magnifier, the information will come from that layer. If I click here, I see a contributing area of 500 cells and something. If I click here, 1. Here, 500 and something else. Here, 1. Here, 1. But if I click here, guess what number I will get? What number?
Huge.
How huge? This is the first cell of the stream segment starts there. It's the headwater starting upstream. So what kind of contributing area am I expecting to find? Something above what? Be more specific. Above what?
1,100
Above our critical source area. Let's see if it's correct. 1,182. Okay? Larger than 1,011, but it means simply that in the neighboring cells have all contributing area that are lower than 1,111. Okay? Okay. Then, of course, this number increases. And if I go downstream, it increases. And if I go downstream a junction from 1,000, something like that, it immediately jumps to a huge number. Okay? Is it clear how it works now? So we classify pixels into river pixel, hill slope pixels based on the contributing area, and the program identify with a single identifier each and every elementary segment. Now, elementary basin. I click on elementary basin and I don't see the segment. Of course, they are below. Let's bring the segments up. Now, Now the segments are up, but I still don't see them. How is that possible? I turn this off, I see the segments. I turn this on, I don't see the segment. Why? This happens because, let me zoom out a bit. This happens because these elementary basins, and you can see this very well if double click, you go to transparency and bring this down to, I don't know, 40% should be fine. So, okay. And I didn't save the project. No, we're fine. And then turn off the DM. These are the elementary catchments that drain into a single segment. So this yellow area is area that is drained directly by all these pixels. How was it possible that the color used for the elementary basing is exactly the same color used by the stream segments? It's possible because the elementary basing are coded exactly with the same number of the elementary stream segment. Help me remember this name. This number 8956. If I click and I click on the segment, no data, but if I do click on the segment, okay, 8956. So this is why the color is exactly the same. They use the same legend, and they can use the same legend because the unique identifier of the stream catchment is also the unique identifier of the elementary catchment. Is this sufficiently clear? Okay. So this is why each and every elementary stream segment becomes colored exactly as the corresponding elementary basing. Let's save the project and stop it right here for today. We will continue exactly from here on the next occasions, which will be, say it out loud, Sophia, please say it out loud for everybody. Next week, classes are cancelled because of the political referendum and the graduation days. There are no classes the whole week next week. Okay, so next time, Monday, TA09, still bring your laptop with QGIS. Lilou, with a working version of QGIS. Good. Let's save the project and close the project.